Yeah, hello. Today I'll be talking about something which we all seem to underestimate in AI systems. It's not data modeling or deployment. It's very primitive. It's data cleaning. So specifically, how do we come to know or make decisions of how to clean the subset of our data and make it more autonomous and transparent and production ready as well using SAS and LLMs. So before starting, some small introduction about me. I am a grad student at University of Michigan, and I currently work on data systems and generative AI. This proposed work came from a very frustration of mine because I spend a lot of time cleaning the data and trying to make sure that I have the right data points with me. And I actually have very less time left to build the models and do something very impactful other than processing the data. So data cleaning is nowadays not a pre-processing step anymore. It's like a bottleneck of modern AI. So nowadays in most workflows, we spend like 60 to 80% of our time trying to process the data and make sure that we are on point. And this is widely considered and observed in data-centric AI research as well. So, and yet, after all of this, we still treat this like a side task. So, the real question is why are we paying more attention towards optimizing the models than making the systems and pipelines more scalable with the general flow that feeds the model. Let's look at the current state. First, the data cleaning process is manual and repetitive, and the rule-based pipelines break the moment we change the data. So we try to fix this with the use of LLMs, but again, that introduces a different set of problems. One being opaque decisions like black box outputs, non-deterministic behavior where we don't understand, we can't backtrack the decisions, the chain of thought of any LLM or generative model. And the last problem is no auditability at all. So, and because of these reasons, LLMs are not used on enterprise level systems because it's unacceptable to not have auditability at all. What we are seeing right now is a shift from pipelines to decision systems and from rules to reasonings. We are moving from static workflows to adaptive agents, and the problem is no longer how do we clean the data, but it's more like what part of the data needs to be cleaned, and we have to be mindful of not just dropping the unuseful data and trying to leverage the available data. So here's the key idea behind our proposed workflow. SAS is extremely good at detecting issues in the data and trying to understand the data patterns, whereas the LLMs are powerful to reason on the data that is provided to them, like any LLM model. So instead of replacing SAS, we combine SAS and the SAS Viya platform and LLM, any open source LLM. I used Llama 3.2 over here. So the basic system execution happens as SAS is the one that detects and LLM decides what happens next. The architecture overview has two extended pipeline other than the LLM pipeline. The first is profiling, where we use SAS Viya Studio for data profiling, and the other is tools. These tools are they build upon the decisions that are being passed on or suggested by the LLM reasoning layer. So there are 4 layers in our architecture. The first is SAS profiling layer, other is LLM reasoning layer, execution layer, and validation layer. So we start with the sales data, very messy data, and we pass it to the SAS profiling layer. We try to use proc contents, which gives us the metadata that includes all the information about our data set, being missing values or any inconsistency that is in our data. After that, we use proc means. Proc means just gives us a distribution of the data, and proc frequency, which is frequency distributions of the data. We combine all of this and we pass this information to the LLM reasoning agent, which then detects the issues and tries to come up with the actions, suitable actions, which can overcome the issues. The output of this LLM reasoning agent can be anything, but we need to make sure that the output needs to be structured in a way that it is auditable and we can backtrace the chain of thought of that generative model. So these decisions are structured, and then the structured decision is then given to the execution layer, where there are certain tools. So ranging from a simple function, Python function, to web searches or different permissions to handle out the research or the planning that the LLM does. So once that is done, we pass on the generated or the clean data set to the validation layer, and we visualize the results. So SAS is critical in this design because it provides reliable profiling, statistical grounding, and the important one is trust. It's actually good to use something, a layer that gives you a more statistically backed data or a more statistically backed metadata to work on, and create a layer that filters out what is needed in your data for the LLM to give or generate a good output. Because LLMs are only as good as the structure you give them. So the proposed system is built on 4 main principles. The first one being separate the detection and reasoning layer. So separating the detection and reasoning layer would make sure that the LLM does not have any access, direct access to the data set. That is important for data privacy. And the other thing is the structure in your inputs and the prompts. The second is always log the decisions. Whatever LLM provides, it should be logged. It should give you a simple chain of thought reasoning of why did it come up with this solution. Otherwise, it's just a black box, and you just can't figure out from where did it, what tool did it use, or how did it get access to certain research papers, or is it making up the answers. So, and the other is validating the outputs. It's very important to validate the output, being keeping the human in the loop. Keeping human in the loop is actually very much essential, because here autonomous does not mean unsupervised framework. This is important. So the screenshot is the terminal screenshot, which gives you an idea of what the LLM outputs when it is given all the metadata. So as you can see, the JSON file or the JSON output would have the issue that is detected by the LLM, the action that it chose, and the reason behind the action that is suggested by the LLM. So it's pretty traceable decision system, and this small design change, it directly addresses one of the biggest like industrial or enterprise concerns, which is trust and governance in AI systems. So this is an extended version of the LLM output. As you can see, it's a structured JSON output, and the main reason of giving it this structure is because it's reproducible, it's auditable, and it can be carried out programmatically. The LLM has no access to the data again. We try to apply imputations and standardization throughout the data types and come up with outlier handling. These are some things that we do in the first step of our data pre-processing layer or the process. So we keep flexibility in the reasoning right now, but we make sure that there is reliability in the execution. So I used sales data and generated a report. So this report is an HTML file with some good visualization. So to your left, there is a demographic. Each node on the demographic means the feature of the column. So as it was a sales data, it has MRP, discount, revenue, and profit. So the red part of the demographic means the raw data, and the green is the clean data. So as you can see across the MRP revenue and discount features, the LLM suggested a lot of action, and the executors planned that and tried to clean the data. So it just shows the null value resolution improvement for the missing values that are present in the green columns. In the right, there's a demographic that shows you how much data was being cleaned and how much is the raw data. After cleaning the raw data, you can still see some gray part which is still missing. That missing part is actually the part of data which the LLM feels complicated. It does not have confidence to answer that or to provide any action regarding that. So that's why we need human in the loop to validate these type of data or these type of scenarios. Once the human in the loop validation is done, this can be then counted in the cleaned or the green part. These are like the waffle charts. The left one is the raw data set, and the right one shows the clean data set. So the left one, if you see, the null values were very much like it was around 5K, but in the clean data set, it was reduced to 1K. Again, this 1K null values are still pending for the human feedback. So this is what we did as in the execution layer. So it was a 4-step execution layer. The first step was typecasting, where features like discount and units sold were assigned floating, were casted floating types, and there was a feature named order data which had strings in it. So we handled that as well. And the next step was to impute the MRP feature with mean. So we did that. All the null MRP values were replaced by the column mean. After that, we tried to apply mode imputation as well. And the last step was outlier capping. So just to make sure that there is no data point that is skewing our data. So what we propose is a continuous improvement cycle over here. It's like we profile, detect, reason with the help of LLM, plan and execute, and validate with human in the loop. And if the human in the loop validation is done in the first round, the LLM can again think of how to improve handling and coming up with good actions for the data that it could not handle in the first round. So the impact over here would be, for data scientists, less time for cleaning and more time for doing impactful work, and more time to iteratively have better experimentation. And for the organization, it would be consistent data quality, faster pipelines, and less risk, less human error. This system has some limitations. The first one being the main LLM hallucination risk. So we need to come up with a good prompt, like a good prompting strategy and a structure that we give to the LLM. Once that is done, we need to figure out the guardrails that we have, and it needs a validation layer. A validation layer would play an important role over here, because we don't want our LLM to output anything that is made up and is not statistically backed. So yeah, autonomous would never mean an unsupervised system. So for future work, we can expand this as we know that SAS-Viya has some introduction of Copilot. So I would want to use a centralized version of Copilot that can combine all the SaaS platforms, and we can work with the Copilot style interfaces and coming up with self-healing pipelines for less maintenance. So yeah, right now we are using tools and extended versions of permissions, but as we go ahead, we would need some systems and frameworks that really are capable of thinking effortlessly, just like us. So the key takeaways over here would be, if we are using LLMs for any use case, we need to make sure and have more time assigned towards augmenting and constraining the pipeline, and making sure that the solution is more observable for your customers and users. And the last thing would be, I would like to say that the future of data science is not better models now. It should be better decisions before we pivot towards, or before the models come into picture. So yeah, that's it. And feel free to connect with me on LinkedIn. I would like to stay in touch with you. Thank you.